All right, so 12 and 13, we've got a situation on 12 that we should be kind of familiar with, or we should recognize it. We've had quite a few questions related to this kind of problem. So we've got a hill right here. So I'm making it into a not so perfect triangle. It's inclined at 13.6 degrees. Whoops. Here we go, 13.6 degrees. And we have a ball that we're trying to figure out what force do we have to have on that ball to prevent it from rolling down a ramp that's inclined at 13.6. So there is this force happening with the ball that's going straight down. That has to do with the weight of the ball. The weight is 27 pounds. Okay, and basically what happens is that we need to project that vector from 27 pounds onto the hill in order to figure out how much of the 27 pounds will actually be going down the hill. And so to do that, that means we need to do the projection of u onto v, which is u dot v over the magnitude of v squared times the vector v. Our u is going to be the vector with the weight of the ball. So 27 pounds going straight down, that's 0, negative 27. Or if you needed to use the angle, that's 270. You could type in cosine and sine with that. And then our v is going to be a unit vector in the direction of the hill. So we're going to use cosine of 13.6 degrees sine 13.6 degrees. So we actually will have to figure out what that is. Cosine 13.6 degrees is 0.972. And sine of 13.6 degrees is 0.235. So now we have u and v. We're trying to find the projection of u onto v because that's going to give us a vector going along this hill to represent what is the ball, what's the force with which the ball is actually rolling down the hill. So u dot v will be 0 times 0.972 plus negative 27 times 0.235. Well, the first part's going to be 0, so that's just negative 27 times 0.235. That's actually in my calculator, so I'm going to do answer times negative 27, so I have less rounding. Negative 6.349 is the dot product. Here's the great thing. Because we picked a unit vector here for v, the magnitude of v squared is 1. You could actually do the Pythagorean theorem on this and do 0.972 squared plus 0.235 squared, take the square root. You'll get something that's 1 or very close to 1. Because remember we had to round here, so it may be a little bit off from 1, but it's supposed to be 1 because this is a unit vector. So what we need to do now is just plug everything into our formula. The u dot v goes on top, and on bottom it's just 1, so we really don't even need that part. V is 0.972, 0.235, and so we just need to distribute this into our thingy-majigger. Negative 6.349 times into our vector is what I meant to say. That's negative 6.171 for our x component, and that's negative 1.492. And that gives us the vector in that direction along the hill, but we actually are going to want the magnitude, because that's what our actual, when we talk about force, we generally are interested in what is the actual magnitude. And so to do that, we do the Pythagorean theorem on this. So 6.171 squared plus 1.492 squared, and then take the square root of that, and you should get 6.349. And that is pounds for our answer. Number 13 asks us to find the work done by a force F of 22 pounds acting in the direction of 1, 2 and moving an object 8 feet from 0, 0 to 8, 0. So there's a formula for work. There's actually two of them on your card. We're going to use the one that says force dot AB, where both of these are vectors, because it's pretty easy to find both of those vectors. To find the vector AB, think about if you're moving from 0, 0 to 8, 0, that's a vector like this, right? So that would be the vector 8, 0. And then the force vector, well, we know the magnitude of it is 22 pounds. It's moving in the direction 1, 2. So we need to figure out either an angle for 1, 2 or a unit vector for 1, 2. So the unit vector for 1, 2 would be 1 squared plus 2 squared square rooted, which is square root of 5, which means that we would divide the 1 and the 2 by square root of 5. 1 over the square root of 5, 2 over the square root of 5. That's the unit vector in the direction that we want, but we need to multiply that by 22 because that's the magnitude of F. So 22 gets distributed in. That gives us 22 square roots of 5, comma 44 square roots of 5. And that's what F is. That's its actual component form. So we're doing F dot AB. So that's 22 square roots of 5 times 8 plus 44 square roots of 5 times 0. Well, this part's going to go away. 22 times 8 over the square root of 5 is 22 times 8 divided by the square root of 5 is 78.71. Where and work is in this weird unit called foot-pounds, but that will be our answer to that.